Hi there, Turgeon here, bringing you Physics from Afar. Rates and relationships. Here's a video. You're about to take notes. Make sure you listen. If you're not hearing the audio right now, you gotta unmute me right now. You're gonna pause a lot. I'm expecting you to take notes, including some extra notes based on things that I say, so you're gonna write more than just what you see. Also, please write any questions down. And don't forget to learn. I mean, I'm not here with you, but just remember that everything we do through videos is also a human to human learning experience. You can get a lot out of it. Some of you already took this entry, so you could skip ahead to entry 7 if you've already done this. But take a second. I want you to think of examples of rates. That's all I'm going to say, just any kind of rate that you can think of. So pause the video and try to write some stuff down. Brainstorm. Okay, so if you just unpause the video, you should have written down some examples of rates. So pause it again if you haven't done that. Think of some examples of rates. For example, you might say miles per hour. You might say dollars per gallon. In my other class, they said beats per minute. So what is a rate? A rate is starting to be some kind of a relationship. It's a comparison between two quantities. There are two quantities. If I say 200 miles in 4 hours, I can write that as a single number that is a comparison. It's comparing the miles to the hours. They're going together. That thing's called a speed. So the speed is related. It's a relationship. It's related to the distance, and it's also related to the time. We often convert that to a decimal. Now, technically, that 50 miles per hour is a decimal. It's just not in fraction form. Notice we hear the word per. Okay, so maybe you're a little confused. You could write some questions down, switch up colors, write extra notes based on things that I'm saying. Because when you submit a photo, I'm looking for extra notes and I'm looking for questions. Entry number 7. You should probably just pause the video and write all this down. I'm going to reveal what's behind the blue boxes soon. Who really won the tower challenge? It's not just about the height. It was also about the mass. So which one should determine the winner? Well, it's not just going to be one thing. We can compare two numbers for this one situation, and they'll both factor into the winner. We've learned now that the height, we don't want to express it in terms of centimeters. We want to express the height in terms of meters. Divide by 100, 100 centimeters in a meter. We don't want the mass in grams. Think about it for a second. We want it in kilograms. Divide by 1,000 because there's 1,000 grams in a kilogram. So which rate is more appropriate to express the winning tower? Think about that. Pause the video for a second if you need to. The rate is meters over kilograms. Remember, that's not mass, that's meters. So big height, small mass would produce the winner. Now, I'm not saying, I just made these numbers up, but I'm not saying that's the winner. We'll see who's the winner. If I do this out, I get the rate of 30.9, and that's meters per kilogram. Again, I'm saying a rate. And notice that the equal sign, when you see that equal sign, it's setting up a relationship. So this index, this doesn't really have a name. It kind of made it up. It's like the tower rate. It's like the efficiency kind of. It's kind of like efficiency. This rate is related to the height and it's related to the mass. So it's setting up a relationship. Again, I'm looking for these extra words, like you probably write the word relationship. I'm looking for extra notes in color on the sides. Do those extra notes. Okay, relationships. Pause the video, write this stuff down. Entry 8. 3 questions. I'll address these verbally. What does this equation show about I and V? What about I and R? And then also there's some stuff going on here. These are real physics equations. These are relationships. They're set up by the equal sign. That would be an example of something you could write down as an extra note, is that relationships are set up by the equal sign. We compare on opposite sides of the equal sign. So I and V, I can tell that if I put bigger numbers in for V, I don't know what the numbers are, but if I put bigger numbers in for V, then I will be bigger. For example, look at these three different fractions. These are not equal to each other. I'm just writing down three fractions. 2 over 10. Let me increase that to 3 over 10. Let me increase that to 7 over 10. If you increase the numerator, but keep the denominator the same, then the rate gets bigger. The relationship gets bigger. In this case, this is, and it's just not just for rates, this is for any equation. If it's in, you just think about what's happening if I put that number in. It might be a fraction, it might be a product of something. So this gets bigger, this gets bigger. I and R, you can imagine that if the denominator gets bigger, then I gets smaller. So for the answer to number 1 is these are proportional. Proportional, P-R-O-P-O-R-T-I-O-N-A-L, proportional. I is proportional to V. I is not in proportional. That's not a word. It's not in proportional. It's inversely proportional to R. So I'll say that again. Extra notes, writing down stuff, and also write down questions that you have. I is proportional to V. I is inversely proportional to R. Inversely. I-N-V-E-R-S-E-L-Y. Inversely. Now look over here. You got F and you got Q. So you got to ignore everything else. Q1. If Q1 increases, what happens to F? There's a relationship here. That's proportional. If this were to double, this would double. If this were to triple, this would triple, assuming I keep everything else the same. The relationship with R is really tricky because it's this R squared. Don't worry about really tricky relationships like that yet. For now, all I want you to think is, if this increases, what happens to this? Well, if this gets bigger, this will get smaller. So imagine R gets bigger. This will get smaller. If this gets 2 times bigger, this gets actually more than 2 times smaller because it's being squared. Relationships are set up by an equal sign. You can literally just look at the equation and it will tell you what's going to happen when you change one thing. How does that affect the other? We use terms like proportional and inversely proportional. So I hope you listened, took extra notes. You're going to take a photo, submit it, showing that you did this video. This has been Turgeon with Physics from Afar.